Hello students, today our lecture is Bessel equation. The differential equation, which is x square d square y upon dx square plus x into dy upon dx plus x square minus n square into y is equal to 0 is called Bessel differential equation, and the particular solution of this equation are called Bessel functions of order n. So today we are going to solve the Bessel differential equation. So solution of Bessel's equation. So we have the equation which is x square into y double prime plus x into y prime plus x square minus n square into y, which is equal to 0. So I can write the second order differentiation of y by y double prime, and similarly dy upon dx by y prime. So this is equation number 1. So let the series solution of this differential equation is to be considered of the form which is y is equal to summation AR x to the power m plus r. You can write it as y is equal to AR a naught. Here the summation varies from 0 up to infinity, so this will be a naught x to the power m plus a1 into x to the power m plus 1 plus a2 x to the power m plus 2 and so on. Now differentiate this equation or this one with respect to x. So we will get y prime or dy upon dx. This will be equal to summation into AR x m plus r, sorry, this is m plus r into x to the power m plus r minus 1, and again differentiating, which is d square y upon dx square. This will be equal to summation AR times m plus r into m plus r minus 1 into x to the power m plus r minus 2. So substitute these values in equation number 1. In equation 1. So equation 1 will be x square into y double prime, which is summation AR into m plus r times m plus r minus 1 into x to the power m plus r minus 2 plus x into y prime, which is summation AR into m plus r into x to the power m plus r minus 1 plus x square minus n square into y, which is summation AR x to the power m plus r. This is equal to 0. R I can write it as when this x square is multiplied with this x, so we will get summation AR into m plus r into m plus r minus 1 times x to the power m plus r minus 2, and here we have 2, so these 2 will be cancelled and we will be left with m plus r. When this x square is multiplied with this x to the power m plus r minus 2, so we will get x to the power m plus r. Similarly, when this x is multiplied with this one, it will give us summation AR times m plus r into x to the power m plus r plus when this term is multiplied with this x square and then with minus n square, so we will get summation AR into x to the power m plus r plus 2, and when it is multiplied with minus n square, so we will get minus n square into summation AR x to the power m plus r, which is equal to 0. Now take common these terms. You can take common summation AR into x to the power m plus r. From this term we have summation AR x to the power m plus r similarly in this term, and similarly from this term. All these terms contains summation AR x to the power m plus r. So taking common summation AR and x to the power m plus r from these three terms, so we will get summation into AR. Here we will be left m plus r into m plus r minus 1, and here in this term plus m plus r, and in this term we are left with minus n square. Times x to the power m plus r, and this is the last term plus summation AR x to the power m plus r plus 2. This is equal to 0. Or we can also write as summation AR when this is multiplied and then added with this term, so we will get when multiplying it with this m plus r, so it will be m plus r square minus m plus r. That m plus r and minus m plus r and plus m plus r will be cancelled, and we will be left with m plus r square minus n square into x to the power m plus r. You can multiply this m plus r with this term plus first, so we will get m plus r whole square, and then m plus r will be multiplied with minus 1, so that will give us minus into m plus r. That minus into m plus r will be cancelled with this m plus r, so we are left with only this term plus summation AR x to the power m plus r plus 2. This is equal to 0. Now in the first summation, if we put r equals to 0, we will get x to the power m, and then equating the coefficient of x to the power m to 0. Let me write it. Equating the coefficient of x to the power m to 0 by putting r equals to 0 in the first summation only. In the first summation, if we substitute r equals to 0 and then equating the coefficient of x to the power m to 0, so if you substitute r equals to 0 only in the first summation, so we will get a naught into m plus 0 whole square, because we substituted r equals to 0, minus n square. This is equal to 0. R a naught into m square minus n square. This is equal to 0. So in this equation, the right side is 0, so the left side, in the left side, either this term is 0, but a naught, since a naught can't be 0 because it is a constant, then m square minus n square, this must be 0, or m square is equal to n square, or m is equal to plus minus n. So when m is equal to plus or minus n, and then for the next coefficient we have to equate the coefficient of x to the power m plus 1 to 0 by putting r is equal to 1 in the first summation here. If you substitute r is equal to 1, so we will get here a1 m plus 1 whole square minus n square. Clear? So this is equal to 0. Here since m is equal to n, if you substitute m is equal to n, so we will get n plus 1 whole square minus n square is equal to 0. Since this term doesn't allow us to be equal to 0, then since m plus 1 whole square minus n square, this is not possible to be equal to 0, because if you put m is equal to n, then we are unable to obtain this term equals to 0. Then the only possibility is that a1 is equal to 0. So we have to find all the coefficients in the series solution of the differential equation a0, a1, a2, and a3. For this purpose, we have to find the succession, the recurrence formula by which we can find all the coefficients. Therefore, equating the coefficients of x to the power m plus r plus 2 to 0 to find the successive coefficients. And this is only possible if we by putting r equals to r plus 2 in the first summation. Here in this summation, if we put r is equal to r plus 2, so we will get x to the power m plus r plus 2, and then equating the coefficient of x to the power m plus r plus 2 to 0. So you can see it here. This is a into a r plus 2 by replacing r by r plus 2 into m plus r plus 2 whole square minus n square plus ar. This is equal to 0. R r plus 2 is equal to minus ar divided by m plus r plus 2 whole square minus n square. So this is the recurrence formula by which we can find all the coefficients. So we have to memorize this formula. By putting, we have found that we already find a0, then we find a1 is equal to 0, then we have to find a2. If r is equal to 0, r is equal to 0. If r is equal to 0, so we will get the next coefficient, which is a2, which is minus a0 divided by m plus 2 whole square minus n square. So this is a2. and for r is equal to 1, we will get a3. a3 is equal to minus a1 divided by m plus 3 whole square minus n square. Since a1 is equal to 0, here you see that a1 is equal to 0. Therefore, this will also be 0. You can write since a1 is equal to 0. And if you put r is equal to 2, you will get a4. a4 will be equal to minus, this will be a2 divided by m plus 4 whole square minus n square. And if you substitute a2 here, you will get this negative sign, and negative sign will become positive, and we will get a0 divided by m plus 2 whole square minus n square times m plus 4 whole square minus n square. So this is a4. So by this formula we can find all the successive coefficients, but remember that all the odd coefficients, which is a1, a3, a5 and so on, they are going to be 0 because a1 is equal to 0. But we are only getting the coefficients, the even coefficient, which is a2, a4, a6 and so on, as a1, a3, a5 and so on, all they are 0. Clear? So putting all these coefficients, putting the coefficients in equation number 2. Here we have to put a0, a1 is 0, we have to put a2, a4 and so on. So by using this equation, y will be equal to, y is equal to a0 x to the power m minus a1 is 0, so this term will be equal to 0, as a1 is equal to 0, so it doesn't need to write this term. So for a2 is negative a0, this will be minus a0 divided by m plus 2 whole square minus n square into x to the power m plus 2, and a3 is 0. Therefore for a4 is plus a0 divided by m plus 2 whole square minus n square times m plus 4 whole square minus n square into x to the power m plus 4 and so on. Or you can also take a naught x to the power m from this equation, common from this equation. Y will be equal to a naught x to the power m. So we will be left here with 1 minus, here we will be left x square divided by m plus 2 whole square minus n square plus x to the power 4 divided by, this is, if you can write this is m plus 2 whole square minus n square times m plus 4 whole square minus n square minus and so on. But also we have find that m is equal to plus or minus n. Here you can see that this is plus or minus n. Clear? By taking square root of both sides, m will be equal to plus or minus n. So if you replace m by plus n, for m is equal to n, this will become y is equal to a naught x to the power n into 1 minus x square divided by if you replace here m by n, so and then open this square, this will be n square plus 4 plus 4n, clear, minus n square. So by simplifying it, this term, first replace m by n, clear, and then by simplification. So this is not a difficult task, you can do it by yourself. I will write it here, 4 into n plus 1, clear. First replace m by n, so it will be n plus 2 whole square minus n square, and then open the n plus 2 whole square formula, plus it will be x to the power 4 divided by, similarly if we replace here m by n, so it will be similarly here and here, and then by simplifying it we will get 4 square into 2 factorial into n plus 1 times n plus 2 and so on. So this is the series solution of Bessel equation of order n. This is called Bessel equation Bessel function. Sorry, this is called Bessel function of order n. Clear? Here this a naught is an arbitrary constant. And similarly, if we replace m by minus n, as you see here, m by minus n, for m is equal to minus n, this equation will become y is equal to a naught x to the power minus n into 1 minus x square divided by 2 into 2 times n plus 1 plus x to the power 4 divided by this is 4 into let me write it as 2 times 2r, you can write it as 4, and this is minus n plus 1, and then this is x to the power 4 times divided by 4 square into 2 factorial into minus n plus 1 times minus n plus 2, and so on. So this is the Bessel function of order minus n. Clear? So in the next lecture we will be going to find the Bessel function, for which we have to find the general solution. So this is sufficient for today's lecture. Thank you very much.